The National Electrical Code, or NEC, does not permit the use of butt splices inside of electrical conduit. The code mandates that all wire splices must be performed within approved enclosures or using splicing methods that are specifically designed and listed for such applications. This requirement is in place to ensure electrical safety, maintain the integrity of the wiring system, and provide accessibility for future maintenance and inspections. Firstly, let's address the general requirements for splicing conductors as outlined in the NEC. Section 300.13. B of the NEC states that conductors must be continuous between outlets, devices, or equipment, and that splices are only permitted in specific locations. These locations typically include junction boxes, conduit bodies, or other approved enclosures designed to provide protection and accessibility to the splice. The primary reason for this rule is to prevent electrical hazards that can arise from improperly made or poorly insulated splices. A poorly executed splice can lead to overheating, arcing, and even electrical fires, posing a significant risk to both property and personnel. Secondly, consider the specific requirements for conduit systems. Conduit is used to protect electrical wiring from physical damage, moisture, and other environmental factors. It is a critical component of many electrical installations, particularly in commercial and industrial settings. However, the NEC does not allow for the creation of splices within the conduit itself because this would compromise the protective function of the conduit system. If a splice were to fail inside the conduit, it would be difficult to access and repair, potentially leading to a prolonged outage or even more serious electrical hazards. Thirdly, let's examine the approved methods for splicing wires in conduit systems. The most common and widely accepted method is to use a junction box. A junction box is an enclosure specifically designed to house wire splices and provide a safe and accessible location for making connections. The NEC provides detailed requirements for the installation and use of junction boxes, including specifications for their size, construction, and grounding. When using a junction box, the wires are run from the conduit into the box, where they are spliced using approved connectors or splicing techniques. The junction box is then closed and secured, providing a protective barrier around the splice. Another approved method for splicing wires and conduit is the use of an approved splice kit. These kits are typically designed for specific types of conductors and applications and include all of the necessary materials and instructions for making a safe and reliable splice. Splice kits often utilize insulated connectors or other specialized components to ensure that the splice is properly insulated and protected from environmental factors. The NEC requires that all splice kits be listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL, to ensure that they meet the applicable safety standards. Fourthly, it's important to understand the consequences of violating the NEC splicing requirements. If an electrical installation is found to be in violation of the NEC, it can result in a variety of penalties, including fines, stop work orders, and even legal action. In addition, a non-compliant installation can create significant safety hazards, increasing the risk of electrical shock, fire, and other accidents. It is therefore essential for all electrical workers to be thoroughly familiar with the NEC splicing requirements and to adhere to them strictly in all of their work. Fifthly, let's discuss the types of splices that are permitted in junction boxes. The NEC allows for a variety of splicing methods, provided that they are properly executed and meet the applicable safety standards. Some common splicing methods include wire connectors, such as twist-on connectors or push-in connectors, and crimp-on connectors. Twist-on connectors, also known as wire nuts, are a simple and widely used method for splicing wires. They consist of a plastic cap with a metal inset that is twisted onto the ends of the wires, creating a secure electrical connection. Push-in connectors are a newer type of connector that allows wires to be easily inserted and removed without the need for twisting. Crimp-on connectors are typically used for larger gauge wires and require the use of a crimping tool to create a secure connection. Regardless of the splicing method used, it is essential to ensure that the wires are properly stripped, cleaned, and connected. The connection should be tight and secure, and the insulation should be properly applied to prevent any exposed conductors. Sixthly, it's important to address the issue of accessibility. The NEC requires that all splices be accessible for inspection and maintenance. This means that the junction box or other enclosure containing the splice must be located in a place where it can be easily reached and opened. The reason for this requirement is to allow electrical workers to periodically inspect the splice for signs of damage or deterioration and to make any necessary repairs. If a splice is not accessible, it can be difficult to detect problems before they lead to a more serious electrical hazard. Seventhly, let's consider the specific requirements for grounding. The NEC requires that all electrical equipment and wiring systems be properly grounded to protect against electrical shock. This includes grounding the junction boxes and other enclosures that contain wire splices. The grounding conductor must be properly sized and connected to the enclosure using approved grounding connectors or methods. The purpose of grounding is to provide a low resistance path for fault current to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. This helps to prevent electrical shock and other hazards that can occur when electrical equipment becomes energized due to a fault. Eighthly, it is important to note that the NEC is a constantly evolving document. It is updated every 3 years to reflect changes in technology, industry practices, and safety standards. It is therefore essential for all electrical workers to stay up to date on the latest version of the NEC and to be familiar with any changes that may affect their work. Many organizations offer training courses and resources to help electrical workers stay current with the NEC. Ninthly, let's discuss some common mistakes that are made when splicing wires in conduit systems. One common mistake is to use the wrong type of connector or splicing method. It is important to select a connector or splicing method that is specifically designed for the type of conductor being used in the application. Another common mistake is to overstrip the wires, leaving too much exposed conductor. This can create a safety hazard and increase the risk of electrical shock. Another common mistake is to under-tighten the connectors, resulting in a loose or unreliable connection. Finally, it's important to ensure that the junction box or other enclosure is properly sized to accommodate the number of wires and splices. Overcrowding a junction box can make it difficult to make safe and reliable connections and can also increase the risk of overheating. Tenthly, consider the use of conduit bodies. While splices are not permitted inside the conduit raceway itself, conduit bodies, such as LB, LL, LR, and T-fittings, can be used to provide access to conductors for pulling, but they are generally not intended for making splices unless specifically listed and marked for that purpose. If a conduit body is used for splicing, it must comply with the same requirements as a junction box, including proper sizing, grounding, and accessibility. 11thly, let's discuss the importance of using listed and labeled equipment. The NEC requires that all electrical equipment be listed by a recognized testing laboratory, such as underwriters' laboratories, or all. This means that the equipment has been tested and found to meet the applicable safety standards. Listed equipment is marked with the testing laboratory's logo or symbol, indicating that it has been certified. Using listed equipment is essential for ensuring electrical safety and code compliance. It provides assurance that the equipment has been properly designed and manufactured to meet the applicable safety standards. 12thly, it's important to remember that the NEC is a minimum standard. It represents the minimum requirements for safe electrical installations. In some cases, it may be necessary to exceed the NEC requirements in order to provide a higher level of safety or reliability. For example, in critical applications such as hospitals or data centers, it may be necessary to use redundant wiring systems or to install additional surge protection devices. 13thly, let's discuss the role of the electrical inspector. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with the code. They typically conduct inspections at various stages of the construction process to verify that the work is being done properly and that all materials and equipment are listed and labeled. If an electrical inspector finds a violation of the NEC, they will issue a correction notice requiring the contractor to correct the problem. Failure to correct the violation can result in fines or other penalties. 14thly, let's delve into the specifics of approved splice kits. These kits are designed to provide a reliable and code-compliant method for splicing wires in situations where a traditional junction box may not be practical or feasible. They are often used in underground installations or in other environments where moisture or corrosion is a concern. Approved splice kits typically include a variety of components such as insulated connectors, heat shrink tubing, and sealant. The connectors are designed to provide a secure electrical connection, while the heat shrink tubing and sealant provide a waterproof and corrosion-resistant seal. The NEC requires that all splice kits be listed by a recognized testing laboratory and that they be installed in accordance with the manufacturer's instructions. 15thly, consider the voltage drop in conductors. While not directly related to splicing, it's important to ensure that the conductors used in the conduit system are properly sized to minimize voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are appropriately sized for the application. 16thly, let's talk about the importance of proper workmanship. Even if all of the materials and equipment are listed and labeled and the installation is in accordance with the NEC, it is still essential to ensure that the work is done properly. This means that the wires must be properly stripped, cleaned, and connected, and that the connections must be tight and secure. It also means that the junction boxes and other enclosures must be properly installed and grounded. Poor workmanship can create safety hazards and increase the risk of electrical problems. 17thly, remember to consider future expansion. When designing an electrical installation, it's important to consider the possibility of future expansion. This means that the conduit system and junction boxes should be sized to accommodate any additional wiring that may be needed in the future. It may also be necessary to install additional conduit runs or junction boxes to provide for future expansion. 18thly, let's address the issue of temporary wiring. The NEC has specific requirements for temporary wiring installations. Temporary wiring is typically used during construction or maintenance work and is intended to be removed when the work is completed. The NEC requires that temporary wiring be installed in a safe and workmanlike manner and that it be properly protected from physical damage. It also requires that temporary wiring be removed as soon as the work is completed. 19thly, it's important to understand the difference between splicing and tapping. Splicing involves connecting two or more wires together to create a continuous circuit. Tapping involves connecting a wire to an existing circuit without interrupting the circuit. The NEC has different requirements for splicing and tapping, so it's important to understand the difference between the two. 20thly, let's reiterate the importance of consulting the NEC. The NEC is a complex document, and it can be difficult to understand all of the requirement. If there is any doubt about how to properly install an electrical system, it is always best to consult the NEC or to seek the advice of a qualified electrical contractor or engineer. By understanding and adhering to the NEC requirements for splicing wires in conduit systems, electrical workers can help to ensure electrical safety and code compliance. This not only protects people and property from electrical hazards, but also helps to maintain the integrity of the electrical system and ensure its long-term reliability. The prohibition of butt splices within conduit is a cornerstone of safe electrical practices, emphasizing the need for accessible and secure connections within approved enclosures.